Next characteristic is going to be turning points. If a polynomial function of degree n, then the graph has at most n minus 1 turning points. And all that means is, if we look at the degree of number 14, the degree is the highest exponent. So this is, you look at the leading term, and I would say this is degree 3. So it can have at most how many turning points? At most 2. Possible. What if I had x to the 5th polynomial? At most 4. Good. What about x to the 3rd? At most 2. Good. So that's the idea. And now we are going to conclude by pulling all this information together and giving a graph of the polynomial function. So we're going to be able to sketch this thing. Okay. Let's first of all talk about our end behavior. Okay. In behavior, if we have x to the 4th minus 4x squared, what's the leading term? X to the 4th. Is it, and my exponent is even, so it means we either both finish up or both finish down. I look out front and it's a positive known 1, right? Positive known 1. So if it's even, will it finish up or finish down? Finishes up. Good. So all I know is I'm going to say, that's going to be my note to myself. Finishes up. Because it's even and it's positive. The next thing we're going to look at is, well, what are the zeros? Remember, to find the zeros, we're looking for the x-intercepts. To find x-intercept, we let y equal 0 and solve, right? So we say x to the 4th minus 4x squared equals 0. And we want to solve this. Let's factor out an x squared to start. If they have something in common, you want to factor it out first. So then we have this. Okay. This, if you don't recognize this, this is difference of perfect squares, and it's simply x plus 2, x minus 2. Or if you didn't know that, we could have said what multiplies to give us 4, but adds to give us 0 in the middle, because the middle term is missing. So we would say, well, a positive 2 and a negative 2, you know, if you added those together. So this is actually difference of perfect squares, so I hope you recognize it by that. Well, now we're ready to say x squared is equal to 0, and then x squared minus 4 is equal to 0. This one just gives us the root of 0. This one would be x plus 2, x minus 2 is equal to 0. So what does this one give us? X equals negative 2. And this one gives us x equals positive 2. Okay, what is the multiplicity of this one? Multiplicity of this one was 2. What's the multiplicity of this one? Known 1. There's a known 1 there. If we don't see it, there's a known 1 there. So this is multiplicity of 1. Multiplicity of 1. Okay, if it has an even multiplicity, this is going to touch and turn. Make yourself a note. That means it's going to cross. It's going to cross. So we look at the zeros, we find where it's going to cross the x-axis, and we also talk about what's it going to do at those particular zeros. Another thing we can come back up here and look at is y-intercepts, which we talked about in the last class. If you're looking for the y-intercept, we let x equal 0 and solve. So we would take our function, and everywhere there's an x, we would plug in a 0. Which is just 0. So our y-intercept is at 0. Which, if you wanted to be precise, the ordered pair would be 0, 0. Okay. D, let's talk about symmetry. We mentioned symmetry before, not in this particular lesson, but we mentioned it in a previous lesson in this course. And this is just for us to have a better idea of how this graph looks. Symmetry, for us to check for even or odd symmetry, we would evaluate f at negative x. Do you remember doing that? That means everywhere in this equation that there is an x, we want to put a negative x in and evaluate. So we would say negative x to the fourth power minus 4 negative x squared. Now, what's a negative to the fourth power? That means negative times negative times negative times negative. It's just going to be a positive. Okay, and what's negative x squared? Positive x squared, so it would be just negative 4 x squared. So, what does this look like in comparison to the original function over here? Term for term for term, it's exactly the same. That means it has even symmetry. It means it's symmetric about the y-axis. So even, it means if we fold it on the y-axis, it should be exactly the same. Okay? Just I'll take a minute. Remember, if it's odd, it would have been completely opposite, term for term for term. Like for this to be an odd function, it would have been negative x to the fourth plus 4x squared. So just a recap on that. Okay, the last thing is at most how many turning points? At most how many turning points? Good, and why 3? Because at most 3 points. Our polynomial is 4th degree. Our turning points can be at most 1 less than that. Good, so now let's put this thing together. We have a y-intercept over here, which is 0, 0, so it means that's where it crosses our y-axis. So let me just put me a little dot there. That's my y-intercept. I have zeros at x equals 0, which it ends up being the same as y-intercept. Let's do x equals negative 2, and let's do x equals positive 2. Okay, our polynomial touches the graphs, has those zeros. It crosses the x-axis or touches the x-axis at that point. Our end behavior, I'm going to make myself a note and I'm going to do this. At some point, I know it both finishes up because of my end behavior. Now, I'm going to take my time and I'm going to go down to negative 2. At negative 2, what will we be doing? Crossing. Good. So I'm going to negative 2 and I'm crossing. What happens when my next 0 is what? My next point that I'm going to go to is 0, but what do I do at 0? I touch and turn around. So I'm going to go up to 0, but when I touch it, I'm going to turn back around. What do I do when I get to positive 2? Cross. And I'm just going to go connect back up. Now, symmetric even means these two should look pretty close to the same. If I folded the piece of paper right here, they should match up. Okay. Now, I didn't give exact values. I just know the general shape of this graph because I didn't know necessarily how far to go down here or whatever without plugging in an x value, solving for a y. But to give a general sketch, of the graph, we can use all the characteristics we talked about today to help us graph this function.